In this video, we're going to look at two different types of addresses: physical, or the MAC addresses, and logical, or the IPv4 addresses. So here we have host H3, and we can see that it has the IPv4 address 192.168.200.3. The network portion of the address is 192.168.200. The host portion is .3. The subnet mask is what defines or determines the network portion from the host portion. So as you can see, actually, in this network here, where this cloud is, all of the addresses begin with 192.168.200. And then they have different host portions of the address. .3 for H3, .4 for H4, etc. In this network over here is the 192.168.1.0 network. So you'll notice that all of these devices have an IPv4 address that begins with 192.168.1. something. So I click on the plus sign here by H8, host 8, and it shows the network address 192.168.1, and the host portion of the address is .4. Okay. So what we're going to do is, if we send a packet from H3 to H8, it uses the IPv4 addresses to do this. The source IP address of the packet would be the source IPv4 address of H3, 192.168.200.3. The destination IPv4 address of the packet would be that of host H8, 192.168.1.4. Those addresses never change. So the source IPv4 address and destination IPv4 address of the packet remains the same as it traverses from one network to another and across as many networks as it takes to get there, to get to the destination H8. Previously, we talked about physical addresses, the Ethernet MAC address. Although not shown here in the animation, let me just explain that the destination MAC address is used to deliver the packet, the encapsulated packet, in an Ethernet frame from H3 to the router. So the Ethernet frame carrying this IPv4 packet would have a source MAC address associated with the Ethernet NIC card of H3. The destination MAC address would be that of the router's Ethernet interface that is attached to the 192.168.200 network. So the source MAC address is that of H3. The destination MAC address would be that of the router's interface on that network. Once the packet is delivered in the Ethernet frame to this router, the router will remove the Ethernet frame. It will then look at the destination IPv4 address of the packet, look it up in something called its routing table, and forward that packet out towards this other network, the 192.168.1.0 network. It will be encapsulated in a new Ethernet frame. The source MAC address will be that of the router's Ethernet interface connected to the 192.168.1.0 network, and the destination MAC address will be that address of the NIC card of host AH. So the key point here is the IP addresses, the source IPv4 address and the destination IPv4 address in the packet remains constant, remains the same as the packet goes from the source to the final destination. The Ethernet MAC addresses, the physical addresses, they will change as they go from one network to another network. The Ethernet MAC addresses, the physical addresses, are what we say are for NIC card, network interface card to network interface card communications on the same network. As that packet goes to a different network, is forwarded to another network, then new MAC addresses, new physical addresses are used for the NIC card to NIC card communications on that network. So for a network professional, it's important to understand the differences between how a logical address is used for end-to-end delivery and how physical addresses, in this case Ethernet MAC addresses, are used for delivery within a network.